Topic of this video is graphing transformation techniques, vertical and horizontal, shrinking and stretching. Let's look at a problem. Graph the function f of x equals 2 times the square root of x. Okay, so we clearly recognize this as a transformation problem. It contains the square root of x, which is one of the functions from the library of functions. However, it's been transformed by this 2. So let's go ahead and set up our transformation. We know that we're going to start with what we understand about the square root function, f of x equals the square root of x. We recall that the coordinates that we associate with that function use x values that are all perfect squares, so 0, 1, 4, 9, and 16, and y's, which are the square root of x. The square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. However, that is not the function we're being asked to graph, which is the transformation part. The function we're being asked to graph is f of x equals 2 square root of x. Don't let the fact that both of these are named f of x confuse you. F of x is just a generic description of an arbitrary function. If it's bothering you, we can always just replace this with a y as a way of differentiating between the two. Alright, so now we have to figure out what are the points of f of x equals 2 square root of x. To do that, we need to know the significance of the 2. First, we look at its location. It is outside far from x, which means it's having a vertical effect. Second, we ask what is that 2 doing? In this case, it is multiplying, which indicates we are dealing with a stretch or a shrink. So, we know we're dealing with a vertical stretch or shrink. Let's write that down. Vertical, stretch, or shrink. We need to decide, is it a stretch or is it a shrink? We recall that vertical stretching and shrinking behaves exactly the way you would expect. If the number is bigger than 1, it's a stretch, and if the number is less than 1 while still positive, it's a shrink. So, because 2 is bigger than 1, we're dealing with a stretch. Vertical stretching involves all of the y coordinates being multiplied by the value, which in this case is 2. So, y coordinates multiplied by 2. All right, so we know that we have to multiply all of our y coordinates by 2. The x's do not change because this is a vertical transformation. Vertical transformations only affect y. Horizontal transformations only affect x. This is vertical, it only affects y. So the x's do not change. Those stay the same. 0, 1, 4, 9. But all the y's are going to be multiplied by 2. So 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. Therefore, these are the points on our transformed function. Let's plot them and then connect them to make the shape that we typically associate with the square root function, which, just as a quick reminder, has this kind of shape. All right, so 0, 0 would be the origin. 1, 2 would be this point here. 4, 4 would be this point here. And 9, 6 would be this point here. Now connect them to form the shape that we typically associate with the square root function. Notice that this is our square root function, but it has been stretched vertically. In other words, it's a little bit taller than what we typically associate with the square root function. All right, this completes our graph. I'd like to say one more thing before we can close this video out. Typically, when I would label the x and y axes, I would label them with 5 and 5 as I've done here on the x and on the y. You'll notice that in green I added the 0, the 1, the 4, and the 9. This is because these are the values that we knew that we would be using for a function that involves square root. So I've included them here as a guide in order to get the correct points on our graph.